Okay, here we're going to talk about the idea behind composite functions. And we know a composite function, f of g of x. What this means is f of g of x. In other words, the value of f depends on the value of another function, and that function depends on x. Now, let me give an example here. A lot of times students don't, what is this? What is this composite function? Let me give a kind of a concrete application type of example, explanation to begin your class with in explaining what this is. Let's say, for example, you go to a still pond and you throw a rock out there in it, and it kaploop, and you get these concentric circles. The area of the circle grows as time moves forward. The longer after you threw the rock, the larger the outside circle. Yeah. So the area of a circle is pi r squared. In other words, the area is a function of the radius. It depends on the radius. But as I just said, when you throw the rock, after you throw it and it hits the water, the radius depends on the time. How much longer after the rock hit the water, how much longer after that are we talking about? The longer you wait, the bigger the radius. So in other words, the radius is we could write it as a function of time. So the area depends on the radius, and the radius depends on the time. This is a composite function. Area depends on the radius, and the radius depends on the time. So that's a nice example to start the composite function class with. That gives students kind of a concrete example that they can kind of feel and relate to later examples when you're finding composite functions and evaluating and working with them.